All right, well, here we are. Question number 44. We're making our way through, aren't we? This is Joe Brownlee with Palm Beach State College, and you are watching the Intermediate Algebra Final Exam Review Series. And the directions for number 44 are: rationalize the denominator, assume that all variables represent positive real numbers, and that the denominator is not 0. Well, we've been here before, haven't we? Rationalizing denominators, so this should be 1, 2, 3 for us. And they give us 5 minus radical 2 over 5 plus radical 2. All right. Well, remember, when we rationalize the denominator, we are going to multiply our fraction by 1 because we don't want to change the value of anything. And the way that we multiply by 1 is using the conjugate of our denominator, right? And the conjugate in this case is going to be 5 minus radical 2. So in order to get the conjugate, all we do is change the sign. All right? And anything over itself is just 1, isn't it? So 5 minus radical 2 over 5 minus radical 2 is 1. And so we're multiplying our original fraction by 1, but it's a special form of 1, and it's the form, it's the conjugate of our denominator. All right, so let's go ahead and put parentheses around each of our numerators and denominators. And on the bottom here, again, like I said, we've got conjugates, but really this is a binomial times a binomial, isn't it? And what do we traditionally do with binomials when we multiply? We FOIL. But with conjugates, we can actually skip the two middle ones. The two middle, our outer and our inner, because when we multiply conjugates, these two cancel out. So really, we're just going to do our FLA, our first and our last. And that saves us an extra step. So what is 5 times 5? Well, that gives me 25. And what is positive radical 2 times negative radical 2? Well, that gives me a negative radical 4. But radical 4 is a perfect square, and it comes out as what? A 2. And so 25 minus 2, well, that gives me a 23. And so our rationalized denominator is 23. But we're not quite finished yet because we have to multiply our numerators together. And in this case, they're not conjugates. You can see that they are the exact same. And so we have to FOIL the whole thing out in order to find out what our new numerator is going to be. Well, what is 5 times 5? Well, again, that's 25. 5 times negative radical 2. Oops. Microphone fell over, but I think we're okay. Where were we? So 5 times 5 is 25. 5 times negative radical 2, well, that gives me a negative 5 radical 2. Negative radical 2 times 5, well, again, that gives me a negative 5 radical 2. And then lastly, negative radical 2 times negative radical 2 gives me positive radical 4. All right, I see I can combine some like terms here. And also, I have a plus radical 4. Well, what does radical 4 come out as? That comes out as just what? A 2, doesn't it? So this is really saying plus 2. And so in that case, I can combine my 25 and my 2. So what is 25 plus 2? Well, that gives me 27. And negative 5 radical 2 minus 5 radical 2 gives me negative 10 radical 2 over my rationalized denominator of 23. And there we have our simplified, rationalized expression, our answer. All right, so again, when we want to rationalize the denominator, the whole point of rationalizing a denominator is to get rid of the radical sign because we can't have a radical sign in our denominator. And so we multiply by 1, but it's a special form of 1, and it's the conjugate of our denominator. And all we do is we change whatever the sign is to the opposite sign. So if it's originally positive, we do a negative. If it's originally negative, we do a positive. We FLA our denominator out, right? We do our firsts and our lasts to get a rationalized denominator. We multiply the whole numerator out, simplify, and we put our simplified numerator over our rationalized denominator, and that is our final answer. 27 minus 10 radical 2 over 23. Well, that was number 44. We're going to move on to number 45. Again, this is Joe Brownlee with Palm Beach State College. Hope to see you soon, and thanks for watching.